Hello everyone, welcome to the first lecture on the electrostatics series और इसमें हम लोग कवर करेंगे the entire chapter of electrostatics. तो इससे पहले कि मैं शुरू करूं, let me give you an overview what are we going to cover in this electrostatics. So in electrostatics we are going to cover the fundamentals of charges, Coulomb's law, electric field, Gauss theorem, and properties of conductors. And there's one more thing. It's not and properties of conductors. There's one more thing. We are also going to cover dipoles. So this is the entire sequence and this is the entire theory of electrostats that we are going to cover. So let's get started and let's start with charges. Now whenever we say electrostatics, it is a word जो कि दो हिस्सों से बना है. It is made up of two parts. Electro, that means electricity, or charges, and static means static, of course, at rest. So we are dealing with charges at rest. The basic game in electrostats is that we are dealing with charges at rest. This is what we are dealing with. We are dealing with charges at rest. Now let's try to understand कि charges होते क्या हैं. In every material that we know of, in every material, जो भी material आप जानते हैं, आपके आसपास कुछ भी रखा हो, आपका टेबल है, एक प्लास्टिक का रिमोट कंट्रोल हो सकता है, आपका मोबाइल फोन हो सकता है, आपकी किताब हो सकती है, चाबी घर की, anything and everything that we know of, any material that we know of are made up of charges. All materials are made up of charges. And there are basically two types of charges, positive charges and negative charges. But we are not going to use this name for a while. अभी हम इस नाम का इस्तेमाल नहीं करेंगे पॉजिटिव चार्जेस और नेगेटिव चार्जेस. अभी हम सिर्फ ये कहेंगे कि मटेरियल दो तरह के चार्जेस से बना है. मे बी सम रेड चार्जेस and some blue charges, and the most important thing here is this, that the red charges and blue charges are equal are equal in number. Now how do we exactly know that they are equal in number, and how do we know that there are two charges at the first place? तो अक्सर आपने देखा होगा कि आप कोई अगर ग्लास रॉड को वुल या सिल्क के ऊपर घिसते हो, या एक सिंपल सी अपनी घर की कंघी, प्लास्टिक की कंघी आप उठा करके अपने बाल पे अगर कई बार घिसते हो, तो यू कैन अट्रैक्ट बिट्स ऑफ पेपर विथ इट. वो कंघी जो है वो छोटे छोटे पेपर के टुकड़ों को अपनी तरफ खींच सकती है, और ये कॉमन एक्सपीरियंस है जो कि आप बहुत ही छोटे क्लासेस से करते आ रहे हो. तो उस कॉमन एक्सपीरियंस को मैं वापस यहाँ पे बहुत ज़्यादा डिटेल में नहीं डिस्कस करूँगा, लेकिन हम ये डिस्कस करना चाहते हैं कि हम साइंटिस्ट ने, हम फिजिसिस्ट ने कैसे समझा या हम कैसे समझते हैं कि किसी भी मटेरियल के पास दो तरह के चार्जेस होते हैं. सो लेट्स सी व्हाट इज हैपनिंग. दिस इज आवर मटेरियल, and as I told you, it is made up of red charges. And it is also made up of blue charges. Now, when you take up another material, let's say this material is B and this material is A. A and B are two different materials. That is very important. A and B are two different materials. It's not that they are any two different materials. ये कोई भी दो different materials होंगे ऐसा ज़रूरी नहीं है, लेकिन बहुत बार ऐसा देखा गया जैसे प्लास्टिक और बाल या फिर ग्लास और सिल्क या ग्लास और वुल. तो इस तरह के सिचुएशन में अगर आप B को A के ऊपर घिसते हो, अगर आप B को A के ऊपर रब करते हो, if you start rubbing B over A, what happens is this. Some of the charges from A, let's say the blue charges from A, let me first draw the red charges and then I'll draw the blue charges. Some of the blue charges from A are actually transferred to B. Some of the blue charges from A are actually transferred to B. And how do we know that they have been actually transferred to B? So if you bring A and B closer together, bring A and B closer, there is an attractive force. There is an attractive force. This force didn't existed before rubbing. Now this is very important कि ये force, this force didn't exist before rubbing. There was actually no force before rubbing, but after you rubbed it and after some of the blue charges from A were transferred to B, between A and B there is an attractive force. A and B try to attract each other. Now, how do we know again that there are two charges? This could be done with just one charge. I mean, if there were just blue charges in the material, अगर हमारे मटेरियल में सिर्फ ब्लू चार्जेस होते तो भी तो ये काम हो सकता था. तो हमें कैसे पता कि रेड और ब्लू चार्जेस दो अलग अलग किस्म के चार्जेस हैं? तो एक पॉइंट यहां से ये निकल करके आता है कि टू टाइप्स ऑफ चार्जेस न्यूट्रलाइज ईच अदर. कहने का मतलब कि जब वो सारे के सारे चार्जेस ए में थे और हमने रब करना शुरू नहीं किया था तो ए फिर किसी ऑब्जेक्ट को अट्रैक्ट नहीं कर रहा था. एज अ मैटर ऑफ फैक्ट, अगर आप अपने पास की कोई भी चीज उठाओ, आप अपने पास की पेन उठाओ या वही कंघी उठाओ जो कि आप अपने बाल पे घिसने वाले हो इलेक्ट्रोस्टैट्स को ऑब्जर्व करने के लिए, अगर आप वही कंघी उठाओ तो आप देखोगे शुरुआत में वो पेपर को अट्रैक्ट नहीं करती है. इट डज नॉट अट्रैक्ट बिट्स ऑफ पेपर. तो somehow we are getting an idea कि दो चार्जेस होना इसलिए ज़रूरी है क्योंकि अगर दो डिफरेंट टाइप्स ऑफ चार्जेस होंगे तो वो एक दूसरे को न्यूट्रलाइज कर लेंगे, मतलब वो बाहरी सब्सटेंसेस पे फोर्स नहीं लगाएंगे. Now that is something that you have to understand, that the two types of charges should neutralize each other. And as a matter of fact, this happens. क्या होता है? after charging when B is brought in contact with A, the force disappears. द फोर्स डिसअपियर्स। कहने का मतलब ये कि जब आप बी को वापस ए से कांटेक्ट में लेकर आते हो तो ये सारे चार्जेस शायद वापस ए में ट्रांसफर हो जाते हैं, या फिर कुछ कुछ इस तरह की चीज़ होती है जो हम देखते हैं कि जब हम बी को वापस ए से कांटेक्ट में लाएंगे यहाँ पे चार्ज करने के बाद, तो ये जो फोर्स इनके बीच में लग रहा है कांटेक्ट में आने के बाद ही वो डिसअपियर हो जाता है। और ये बात आप देख सकते हो कि एक बार अगर आप अपनी कंघी से उन पीसेस ऑफ पेपर को, उन बिट्स ऑफ पेपर को अट्रैक्ट कर लेते हो और फिर उसके बाद आप उसे अलग करते हो, तो आप ये पाओगे कि उनके बीच में फोर्स या तो कम हो जाता है या फिर नेग्लिजिबल हो जाता है। नाउ देयर इज अ सेकंड पॉइंट टू दिस, अ वेरी इंपॉर्टेंट पॉइंट टू दिस, कि अगर हमारे पास ए जैसे दो मटेरियल्स हैं, लेट्स से वी हैव अ मटेरियल ए एंड वी हैव अ मटेरियल ए डैश, और इसमें भी रेड चार्जेस हैं और ब्लू चार्जेस हैं, और इसमें भी रेड चार्जेस हैं और ब्लू चार्जेस हैं, और इक्वल रेड चार्जेस और इक्वल ब्लू चार्जेस हैं, तो इन मटेरियल्स के बीच में अभी कोई फोर्स नहीं है, देयर इज नो फोर्स एज ऑफ नाउ। लेकिन फिर आप एक यहाँ पे दूसरा मटेरियल लेके आते हो बी, जिसको आप इस पे घिसते हो, यू स्टार्ट रबिंग इट, और यहां पर एक दूसरा मटेरियल लेके आते हो बी डैश, जिसको आप घिसना शुरू करते हो, यू स्टार्ट रबिंग इट। इंपॉर्टेंट चीज ये है कि ए एंड ए डैश आर मेड अप ऑफ सेम मटेरियल and B and B dash are made up of same material। तो घिसने के बाद ऐसा होगा कि B के पास कुछ ब्लू चार्जेस आ जाएंगे, B will get some blue charges and B dash will also get some blue charges। B dash will also get some blue charges। और जब आप B और B dash को क्लोज लेके आओगे, when you bring B and B dash closer together, you will observe that there is a repulsive force between B and B dash। Now this is an important observation। अगर आप अपने बाल पे दो अलग अलग कंघियों को रब करते हो, if you rub two different combs on your hair and you try to bring those combs closer together, you will observe that the combs have a repelling effect। They do not have an attracting effect, but they actually have a repelling effect। So let me keep this in focus here। So B and B dash repel each other। Now this is the second proof that tells us that there must be two types of charges। Why this is the second proof? क्योंकि अगर एक ही टाइप के चार्जेस होते तो एक ही टाइप का फोर्स होता। If there was just one type of charge, there must have been just one type of force। Now this is important। If there was just one type of charge, there will be just one type of force। But now since there are two types of charges, since we have, because we don't have a one type of force, since we have two types of charges, we have two types of forces. Have two types of forces. Now there is something else that we come to know about the properties of charges, and that is that the like charges, they repel each other. So whenever we have, let's say we have a large amount of red charges in A and a small amount of blue charges, so basically we can say that red charge is greater than blue charge in both of them. So in A and A dash, both of them, the red charge is greater than the blue charge. So we will find that in case of A and A dash, they also repel each other just like B and B dash. A and A dash repel each other just like B and B dash. There is a repulsive force. So we come to the following two conclusions, that like charges repel each other and unlike charges attract each other. Like charges repel each other and unlike charges attract each other. And this is the fundamental theory behind the charges. But there are some other properties of charges that you have to understand. So we will summarize the properties of charges. Properties of charges. The first property is that there are two types of charges. Types of charges. And now since we were saying that they were red and blue, now we will call them positive and negative. So the red charge we will call as the positive charge and the blue charge we will call as a negative charge. and क्यों इनको पॉजिटिव और नेगेटिव बुला रहे हैं, इसका डिस्कशन अभी हम बाद में करेंगे. वी विल डू अ मोर डिटेल्ड डिस्कशन व्हेन वी आर स्टडीइंग फ्लक्स एंड इलेक्ट्रिक फील्ड, बट राइट नाउ वी कैन जस्ट अज्यूम दैट इट इज अ कन्वेंशन. We can assume that it is a convention for now. अभी ज़्यादा दिमाग लगाने की ज़रूरत नहीं है. We will just assume that it is a convention, that there is a positive charge and there is a negative charge. The red ones will be called as the positive charges and the blue ones will be called as the negative charges. Universally, the charges that are transferred on rubbing are the blue charges or negative charges. Only one type of charges are being transferred and they are the blue charges. And why are they being transferred? That they are being transferred because blue charges or negative charges are relatively free to move as compared to red charges or positive charges. The red charges or positive charges are more tightly bound to the atom or to the material, and the blue charges or the negative charges are relatively free to move. So the transfer that takes place happens with only the negative charges. The transfer doesn't happen with the red charges or the positive charges. So this is an important concept that holds the properties of charges. The third important concept is that the charges are additive. The charges are additive. So you can fundamentally add them. That is, for example, if you have let's say 6 blue charges plus 2 blue charges, you will have 8 blue charges. Or the other way to say it would be, if I have 6 negative charges plus 2 negative charges, I'll have 8 negative charges. Or if we have 4 red charges plus 3 red charges, we will have 7 red charges. Or the mathematical way to say it is that if we have 4 positive charges plus 3 positive charges, we will have 7 positive charges. But what if there are blue charges and red charges? So let's say if you have 6 blue plus 4 red charges, then the overall charge that you're going to have is 2 blue. And why is that? That is because you have 6 negative charges plus 4 positive charges, and since you are adding positive and negative, so you'll have -6 and +4 simply as you add it on a number line. So you will have 2 negative charges. So you can fundamentally add charges if with their signs. The charges are additive with their signs. That is the idea, with their signs. So that is important कि आप कभी भी charges को जब add करेंगे तो उनके signs के साथ add करेंगे. Moving on, the next property is, let me keep this here. The next property is that the charges are conserved. Charges are conserved. You can never actually create or destroy charges. So if a material has let's say it's highly unlikely, but just for the sake of simplicity, if the material has 12 red plus 12 blue charges, 12 red plus 12 blue, or every time I'm writing red and blue, I'll say 12 negative, 12 positive and 12 negative charges. So the overall charge is equals to 0. Now what happens is, if you start rubbing it with some other material, so if you have let's say a comb or something like that, and you start rubbing it, then some charges are actually transferred to the comb, So let's say the comb gets 6 blue charges, or let's say only 4 blue charges. The comb gets 4 blue charges. So what are we left with here? We are left with here is 12 red charges and 12 minus 4, that is 8 blue charges. We are left with 8 blue charges. So that is something that you have to understand, that you cannot actually create charges, you cannot destroy charges, but you can only transfer charges. You cannot, let me write this, you can't create or destroy charges, but you can only transfer them. You can only transfer them from one material to the other, from one material to other. one material to other. So this is a very important concept of charges, that you can actually never create them or destroy them. You can simply transfer them from one material to other. And the last property of charges, let me keep this here in focus. All right, maybe okay. And the last property is that charges are always quantized. Now this here is a very important principle. This is called as quantization. Now what does quantization mean? Now maybe in class 11th chemistry, and I'm sure you know something, and even in class 9th and 10th you have learned that charges are made up of fundamental units. Let's say the blue charges or the negative charges are made up of fundamental units called electrons. Now the idea is that there can be one electron. Let me write this. There can be one electron or two electrons or three electrons or four electrons or 1,000 electrons, or 3, 7, 4, 5 electrons, but there can never be 1.5 electrons or 4.7 electrons or 6.9 electrons. So this is not possible. So this situation here is something that we are saying is not possible, because the fundamental units are electrons. The fundamental units are electrons. So this situation here is not possible. So whenever you have charges, it appears it is a fundamental integral value. So any charge, let me write this properly, any charge is the integral value of the charge on an electron. Any charge is the integral value of the charge on an electron. And what is the charge on an electron? The charge on an electron, I think we know the data to that. It's approximately, not exactly, 1.6 into 10 to the power of minus 19 coulomb. And if the charge on an electron, or let's say if the unit of negative charge or blue charge, as I was calling it before, is 1.6 into 10 to the power of minus 19 coulomb, then the unit of a positive charge is going to be the same. The red charge is going to be the same, is also 1.6 into 10 to the power of minus 19 coulomb, because in any material, if we have, let's say, n number of red charges. So right now, how many do I have? 1, 2, 3, 4, 5, 6, 7. Maybe I'll draw a few more. 8, 9, 10, 11, 12. And then I'll have an equal number of 6, 7, 8, 9, 10, 11, 12. And then I'll have an equal number of positive as well as negative charges, and that's what makes a material neutral. Right? So these are the properties of the charges that we have discussed in this video, and in further videos we will discuss more and more concepts on electrostats. So meet you in the next video. Thank you very much.